Hey guys, today welcome to another episode of Coordinated. Today we have somebody which is not a very conventional protocol in my understanding. So we have the founder of Predicate. So when I first heard about Predicate, I think a couple of months back, I think back then it was known as Ethos or something similar. So I just like read about that thing. Okay, they're doing something about like pre-transaction stuff. So in my mind, I was thinking it would be something related to mempool, something related to extra like block headers or some extra data in the transaction set or some kind of that. But when I saw, okay, it's a policy engine and doing something in that part, and there are many things which are like option parts and which are actually coming from the public policies or the on the other related stuff. So I was like, okay, amazed by all this thing. Like they're the category creators in Eigenlayer in this space. I think nobody is building a policy engine for sure in the entire Web3, also in Eigenlayer. So yeah, I think like that like and I wanted to talk with the Predicate team and like obviously Nikhil, the founder from then only. So welcome to the show, Nikhil.
Thanks so much for having me. Excited to be here and talk more about what we're doing at Predicate.
Sure. Thanks. Thank you so much for joining. I think before we like talk about little bit about what predicate, like what is about predicate, I want to like take a step back and want to know about your background. Like I was studying about your background. You have like pretty much very detailed kind of like activities in various impact and public consulting space. So before we go and deep into predicate, want to know like what attracted you to like public policy and impact consulting space.
So
Yeah,
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 my
sure.
interest for public policy really started around this idea, and this was going back to when I was younger, when I was in college, was very much around the allocation of resources and how the allocation of resources, the movement of money, the movement of social capital, all of those things, and the systems of power within all of that. How does that drive kind of the influence on society, right? How does that influence, like what are the things that are done? What are the things that are done from a public work standpoint? What are the things that are done from a private standpoint? How do the pieces all connect together? So that was really my interest. And then later on over time, it was much more the intersection of policy and technology, because you really cannot separate the policy implications on technology and vice versa, right? Because technology influences so much of our day-to-day lives. And there's a lot of different facets of that, right? We've seen early internet, we've seen, all like social media applications, we've seen, things like Netflix, Google, Uber from a rideshare standpoint, we've seen autonomous vehicles more recently, of course, AI, and then digital assets. That influence of how does it affect people? That was really the early interest for me from a policy standpoint. But that being said, I've spent a lot of time outside of that as well, in economic consulting and management consulting, and then crypto for a number of years now as well.
Cool. I think at one point I also thought okay, I'll study about public policies and all because of how I have observed myself over the years. Like I want to obviously create wealth for myself, but I think if the impact factor is not coming in, I am not motivated enough to chase the wealth factor. So I also researched about this kind of thing, and I really attracted by the people who are in this space. I think we can talk much more about this sometime later. But one thing I want to ask about you because you have spent a lot of time about thinking about resources allocation and all. Like, what's your general thought about capitalism and how the current world orders are moving towards it? If you can share something about that.
Yeah, that's a broad question. So in the way of how we think about capitalism, right? And so the way I see it is that you've had allocation of resources that are now heavily concentrated. It's in the US, it's in India as well, it's in China and most major markets. You've seen a consolidation of resources around a smaller set of people. And then of course that feeds into itself, right? Where wealth then continues to accumulate around a smaller and smaller set of people. Of course, that what that means is like widening economic and income inequality. And that is a policy issue, right? Because that then affects how we think about the allocation of resources, the movement of resources, both within a region and more globally. And that is where I think something like crypto is quite fascinating, because let's take even my first early interest in crypto was really around emerging market payments and cross border payments, where moving money anywhere in the world involves a lot of intermediaries that are really just taking various fees and wealth in this entire process. What does that mean is, a large financial institution can move money globally. right? They have all the resources to be able to do that. But everyday people, individual people, it becomes much more difficult, right? Like if I'm sending money from India to the US or vice versa, or if I'm sending money anywhere else, like sending smaller retail payments are just generally cost prohibitive. And so that was an interest in crypto. And then the added benefit there was your centralized institutions that are your kind of accumulators of wealth. For them, what they're thinking about is how do I continue accumulating wealth? They're not really interested in necessarily serving people unless it accumulates their wealth. And so that means that from an ownership standpoint, they own all the resources. Uh, this is like one of the challenges of capitalism, right? Is that from a capitalism standpoint, yeah, you're thinking about allocation of resources going to the most efficient places, and those groups being financially incentivized because they're saying, oh, I can earn more revenue and more wealth by continuing to widen the economy and broaden my services. But at a certain point, that doesn't always hold, and I think we see that when it comes to a lot of traditional financial systems and how money moves. And that was my interest for crypto is what if you can actually have true ownership across people? You're not reliant on a centralized provider who's a rent-seeking actor, who's like, how can I collect as much rent from all these different things? But rather, if you spread that ownership, you can actually bring overall costs down for everyone. And that I think is like one of the fundamental challenges of capitalism that we have to reckon with is the accumulation of resources and then rent-seeking and monopolistic behavior. Everyone wants to be a monopolist, right? Like that is the end outcome for anyone who is working in a capitalist system. That is ideally what you want to do. And then you're assuming that a government is the one who's putting in anti-monopolistic rules and laws, but that doesn't always happen either. And so I think that's really how I've been thinking about capitalism more broadly.
Mhm. I
And
think
that's obviously a quick snippet of what is a much longer conversation we could have.
sure. I think yeah. As I was telling you, I don't want to get into all this thing because we will deviate from the core topic of our today's discussion. But I think you've already like set up the basics, like bringing in crypto aspect here. Like basically, crypto is kind of breaking the monopolistic aspect of capitalism, and it's giving a like a proper space. So you have to build it, obviously, proper space to allocate resources to mass. So like
Yeah.
as you, like brought the concept of crypto here, I just want to know I think you touched it very lightly, but want to know what was your entry point to crypto, and like then what led you to start Predicate, like if you can map out the entire journey.
Yeah, so my entry point into crypto was at Cello, very much on that idea of cross-border emerging market finance and payments, and it was entirely because I said what the great thing about crypto and blockchain and digital assets is the ownership part of what if people can actually have ownership over their financial system, whether that is locally, whether that is globally, whether that is within your family, whatever that is. What if you can actually have ownership over that? Because ownership is real power, right? If you have ownership over it, then you can determine how it is used. You yourself have power over that. You can build new things that are on that system. And so that was my entry point was Cello. Spent a few years there, and then worked really across the ecosystem, supported a lot of different projects on Cello, across DeFi, NFTs, climate finance, social impact use cases, payments, across kind of the entire spectrum. And during that time, as I was working with a lot of projects, there was kind of a common pain point that I was seeing across many of them as they were scaling was how do they deal with kind of the increasing complexity as you're taking your project and touching the rest of the global economy, whether that is your business requirements, whether that is legal and regulatory, any of these kinds of things, and how do you actually deal with those things within the protocol or within the application that you're building. And that was really what led me and my co-founder to start working on Predicate, because we said, hey, there has to be a more common way of being able to simplify some of the technical challenges that all these different groups are facing. And we were seeing that across a number of projects that we're now working with as well. But it really started with there's increasing complexity in the world, and navigating that increasing complexity, if you're a developer, if you're an application, requires something like Predicate. So yeah, that's how we basically left Cello last year in the fall, in 2023 fall, and I've been working on Predicate since then.
Nice. I think like this will obviously lead to the next question. Like what is Predicate? Like I just saw a like simplified transaction prerequisite. Uh, understand a little bit here and there. Like those are kind of predefining the various policies and other off-chain complexities. Like I saw you giving this analogy a lot, that Airbnb, Uber, and Netflix, how they are kind of mapping their, like how they have mapped their policy setups behind the transaction. And like I drew some analogy towards it, but I think now we have you, so I want to know, like you can go as detailed as possible. What is predicate?
Yeah. So taking a step back, if you're an application in web in crypto, and you're thinking about how to scale, you're building out new systems, you start having more complexity. And that complexity really comes down to pre-transaction logic. And so you touched on some of the Web 2 pieces, but let's start with Web 2 and say, cool, what was going on there? And so a few examples. Let's go with, let's start with Uber. So Uber, when you request an Uber ride, what did Uber really want to do? They were like, we have to give riders the most seamless experience to move around, right? Like that's what they really cared about. How can they have it that within a phone you can request a ride to where you need to go and the car will come and pick you up? You don't have to put in any additional payments. You don't have to think about the route. It will simply get you to where you need to go. Everything is taken care of because you've already set it all up. That was what Uber wanted. Now, to do that, there has to be a lot of things that are done on the back end to simplify that rider experience, right? So when you call an Uber, on the back end, it's doing a number of different computation. It's really checking and saying, okay, what is your Uber rating? Where are you trying to go? Where are you calling it from? What kind of car did you request? What is the traffic like? All of these different things. Should there be surge pricing? All of these types, all these different aspects, right? And it's using all of that to match you to a driver to give you the most seamless experience possible. This is really pre-transaction logic. All of this is being done before you are being matched with a driver. Similarly, now let's take another example, PayPal. When PayPal was building out their entire payment platform, a big concern that they had was they were worried that you're going to have a lot of scammers who use the platform, which would then make it unusable for everyone else. And so what they did was they built on the back end what they called a policy engine. And the policy engine was utilizing heavily around like graph technology to say, we want to be able to basically like block scammers from being able to use the platform or interacting with people. And so again, all of that is pre-transaction logic, right? It's looking at historical actions by different people saying, hey, wait, these are anomalies, these look odd, these are scams, all of those things. And you're setting up an entire system of basically saying there's going to be certain users who cannot interact on the platform. This is PayPal's determination, right? It is a form of censorship that they're saying there's certain people who are just not going to be able to use the platform because you didn't abide by our terms and conditions. So Uber and PayPal both have this entire notion around pre-transaction logic. And then the third one, another good example, is something like Netflix. Netflix has geolocation, right? And the reason why, the biggest reason why Netflix has geolocation, part of it is geofence of like I can't go and watch things from other places, but it's really because from a business case they're doing all these different media partnerships to give users custom and curated experiences depending on where they live. It's a user experience standpoint. That's also pre-transaction logic. If you try and go and interact with Netflix in one country, what do you see versus if you're going from another country? The point here is for all these companies, as they scaled and as they're thinking about how do they reach different users and consumers and for their business needs, they had to put this in place. And that's really what we see in crypto for our organizations as they start scaling. When they're starting to connect to traditional financial institutions, when they're starting to connect with different users around different parts of the world, when they're like, oh, we're creating different types of asset pools, and we have to think about who we can market to, who we can't market to. All of these things are different types of complexity. In all of those cases, you need pre-transaction logic. So then, as that application, you can either choose to go and build it yourself, right? You can go and say, we're going to go and do this. We're going to spend the time to build it. We're going to spend the time to maintain it, update it, all of those things. But the great part in blockchain is that you don't necessarily need to always build everything yourself. You can actually use building blocks from other systems. And so that's what we said from Predicate was, what if we can build a common mechanism, common system in order to enable your pre-transaction logic for whatever type of logic you might need that is done? What if you don't have to build it? Because it's actually not usually part of your core work. Your core work is going to be other things as a developer. And so you can offload that work over to something like Predicate. And that was really what we're doing.
So, like, want to know more about what this pre-transaction logics are? Like, basically, initially how I was conceptualizing was, okay, since you have that like public policy and impact consulting background, and I was thinking, okay, this might be when we take blockchain use cases to mass, and or we when we have to interact to government. So
Yeah.
we all, like, there are this pre policies which government impose that you want to bring on chain, but then I figured out, no, there might be something other than those defined policies. So want
Yeah.
to know what kind of policies we can like use before a transaction gets start processing, and what kind of policies like predicate is tackling there.
Yeah, so for us, it's really broadly any type of pre-transaction logic that leverages any on-chain, historical on-chain information or off-chain information. So the universe really becomes infinite depending on like what you're doing. But let's go through a few sample ones, right? So you said one, given my policy background, like probably some government-related regulatory stuff, and that's right. So predicated can be used for AML, anti-money laundering policies and requirements. So how can you, as an application, say we don't want assets originating from a sanctioned entity, or from like child exploitation, like human trafficking, and those kinds of things? How can you actually prevent those funds from entering into our application, our ecosystem? And this could be, an individual kind of developer team saying, we don't want to touch this for legal reasons, but it can also be a community, right? It can be a DAO saying, look, like we just fundamentally believe that we don't want funds coming from certain people because we don't want to touch it as individuals, because we have values as individuals. The same way that you or I, when we go and spend money somewhere, we do make a value judgment of where we spend money. And communities will likely have those types of preferences. And so anti-money laundering is one. That's an example. Another one is, let's say there's an exploit and you don't want the funds from an exploit to come into your system or even to go out somewhere. So you can also think about anomaly detection as a pre-transaction logic, exploit mitigation. So if an exploit happens, how can you restrict where those funds might go? Or how can you say, I don't want these funds here. Your money's no good here. But then going wider out, like other ones are stablecoin minting requirements. So what are the requirements in order to mint a stablecoin? It's not really a necessarily a regulatory thing. In some cases, it might be. In Europe, it might be something like Mika, where there are like stablecoin rules and regulations. But if you're a decentralized stable, even from a business standpoint and a protocol standpoint, how do you put in place the infrastructure where you'll have, pre-transaction logic in order to be able to mint a stablecoin? So that's a different use case. And then going into the world of even something like intents, which becomes very broad. So in intent systems, you could, express as a user, how do you want your transaction to be processed outward? So when you send a transaction, what pathways do you want your transaction to go through? Where do you want it to go? All those types of things are logic that you will want specified before the transaction itself is executed by solvers. And then similarly, if you run solvers or if you're an LP in solvers, you may have preferences for what liquidity or what transactions you're actually solving for. So again, that's pre-transaction logic either for the user side or for the solver/LP side. So it's really around how do you, more broadly speaking, make transactions more expressive. And you can't do that just on a smart contract platform by itself because you don't have that compute capability on chain. Uh, you require something like predicate to be able to do that compute, the off-chain compute. And that's really where we come in.
So like, okay, I'm assuming like predicate is like not live yet, or like protocols haven't used yet. Like even if some projects are building, I'll come to that section later. So how currently, because money laundering intent solver space is also going up a lot, how these are tackled currently, like without predicate, and like if you
Yeah.
can say.
So Predicate is actually live with one project, and we're going live with some more this year, and then we'll continue with it next year as well. But how projects currently tackle something like AML is they won't have something necessarily at the smart contract level. They will usually have something at the UI where they'll use something like a chain analysis or a TRM where they'll have some type of external call that's made from the UI. The challenge, of course, is a malicious actor never uses a UI. They'll just go interact directly with the smart contract, right? Or they can also spin up their own UI. So that's usually how it's done, is on the UI. The other option, of course, is you do KYC. You require every single person to be KYC'd. That fundamentally breaks the user experience because KYC platforms are usually not super effective. Not everyone is able to KYC. A lot of people are just don't have the things to KYC. And so a lot of groups don't do that unless they're like operating in highly, highly regulated markets. So the two primary ways right now are very much either from a UI standpoint or just KYC. What we are doing is different in that case. You can actually do flow of funds checks based off of historical off-chain information and tracking flow of funds real time. And then we're also able to work with different risk score providers whose data can be executed at a smart contract level through something like Predicate. So that's how we can do AML very differently. For intent systems, I would say like those are still most of them are not live yet, and so in that case, it's still like very much more of a TBD on how they would do it if not for something like Predicate. That part I'm not sure. I think they would likely build out their own type of logic systems themselves.
Another thing, as you mentioned, what I am assuming, correct me if I'm wrong, there are many off-chain components which are involved here. Like, talk about the external policies being on-chain. Talk about the intent system and the solver network, which is kind of the outside of the system. So, like, how you are kind of bringing this off-chain components on-chain in predicate
Yeah.
system.
Yeah, so let's start with first setting the policy or the requirements. So that the developer is able to set, and that's actually basically stored on chain on Ethereum. Then we have our off-chain operators. So this is where Eigenlayer comes in. So we have a network of operators that are responsible for checking any transaction that's going into a smart contract or a solver network or a sequence or really anything that's kind of touching that on-chain component. And the operator network, the predicate operator network, is responsible for basically checking every transaction. And what they do is transactions are broadcasted from the predicate, basically from that application over to the operator network. The operators reference the on-chain policy that's set, and they said, okay, cool. This policy tells us to go and check X source of information, do X compute, whatever that is, and then say whether the transaction meets the specific policy or not. If it does, the operators issue a signature. The signatures are issued on chain. If it doesn't, the operators don't issue a signature. And so what you really have here is a generalizable system of signature issuance. And the signatures are really saying whether a transaction meets a policy or not. That's how this whole system works. So you have the off-chain compute that's done by the network of operators. You have on-chain signatures that are issued, and then you have the policy that is stored on-chain. And then, of course, how the transaction is executed varies, right? You have in intent systems, you have solvers. Solvers are off-chain, so solvers can plug into the predicate network. A smart contract can plug into the predicate network. That, of course, is on-chain. All these different things utilize the predicate network for their pre-transaction checks.
I think, like obviously, Eigenlayer unlocks, I think, the main part of what predicate does. Like, did you conceptualize the predicate platform before Eigenlayer came, or were you thinking, okay, and then Eigenlayer somehow came and that thing like fit in your logic? Like, what was the thing with like choosing Eigenlayer in the plan?
Yeah. So what we first started with was we said that in the beginning, we're like, do we need anything that's decentralized or need something, or is it okay to be centralized? That's how we first started. This is pre-Eigenlayer. And as we were talking to a lot of applications who were going to integrate Predicate, they said that they would need something somewhat more decentralized. And the reason why is they said, hey, look, we're building on a blockchain. We have an application that's smart contract enabled. Yeah, you have immutable contracts, but the whole point is that we have some type of decentralization here. And if we integrate a centralized system, the vulnerability here is now you're now saying that Predicate is a central point of failure, right? There's a concern around latency, uptime, verifiability, all of those things. And now you're saying we're going to trust this centralized provider to be good on all of those fronts. So we said, okay, great. That might be a problem. And so a lot of our partners were like, we need something more decentralized. So we said, okay, great. We're going to build a more decentralized operator network. The best ways to do that was either to build a proof of authority model, a bit like how Wormhole approached their Guardian network, or a Cosmos SDK, which would involve, launching a token pretty quickly. You have to bootstrap your network. Axelar is a very good example of a Cosmos SDK style approach for cross-chain messaging. So think of it as like the Wormhole versus Axelar choices. Then Eigenlayer came along, and we knew the Eigenlayer team for some time because when we were at Cello, we were already talking to Eigenlayer about EigenDA, right? So this was like beginning of like early 2023, we were already talking to Eigenlayer. And then I was talking to Sriram and I said, hey, wait a second, like, isn't this technically what you guys are able to solve for, is us to bootstrap our operator network so we don't have to go and do this? And he was like, that's exactly what Eigenlayer is able to do. And so then we said, okay, great, let's spend a little bit more time digging into Eigenlayer and see if it makes sense. And we realized it makes a lot of sense for us if we're trying to bootstrap a decentralized operator network so that we as a team can go and focus on what we really are trying to do. Our focus is around building an entire system for pre-transaction logic and policies. By working with Eigenlayer, we spent less time having to go and build out our entire operator network. And so when we think of our overall network, one side of that network were operators. And through Eigenlayer, we basically had to spend very little time on actually doing that. And that would have meant that lets us move faster, lets us go to market much faster. That lets us do integrations with different partners much faster. Otherwise, right now, we'd be talking and saying, oh, we're working on getting our operator network and we're talking to different potential operator partners. We already have that ready to go.
By the operator network, correct me if I'm wrong again. So basically, this Eigenlayer operators, right? They come, they see the AVSs, and they select, okay, this AVS is kind of giving me this reward. This is the risk ratio, and I'll like choose, let's say, predicate. Is it something like that? This is how the operator model comes in.
Not quite yet in terms of how operators are making decisions. I think operators generally are working with many of the AVSs because there's no slashing and there's no rewards yet from most of the AVSs. So right now it's very much a future reward versus a present day one. And a lot of the operators work with the LRTs. So from a predicate side, we work with LRTs and operators directly.
So is there any like pre-assigned conditions now? Because we know, as you mentioned, slashing and reward part is not yet live, and we don't have that end goal, or let's say the goal in next 1 year or less than that. Here there is a permissionless marketplace. Let's say I'm an operator. I'll see, okay, predicate is giving me this kind of rewards. These are risk. Let's pin a AVS node. So how's the current structure? How you are working with operators in the current model?
Yeah. So how we work currently with operators is because we're not providing any rewards. So that being said, there's no slashing conditions right now for predicate either. So really, it's just there's no risk for an operator to run a system for predicate. The only real thing, the only cost item. So the cost items for an operator are usually the risk of slashing and the overhead for running a machine. Right. Those are the two items. Right now, there's no slashing. So the main overhead for an operator is that, oh, they're running a machine for predicate, for compute. But in the same way, they're running machines for a bunch of other AVSs as well, who also don't have slashing conditions. So right now, the way we work with operators is we do have operators who run our client, and we have them update every few weeks as we have new operator releases. We work directly with them. We talk to them. And right now, they basically run the operator. They're expecting some form of compensation or reward in the future, but that is across all AVSs across Eigenlayer, because right now it's, they work with us, they work with other AVSs, and they're expecting kind of an aggregate form of return sometime in the future. This is what LRTs are also thinking as well.
Okay, I think before we move forward, I have one question, that is, with predicate, right? How somebody will think mentally, like how the with predicate integration a transaction life cycle will go. So if how we know, right? I place a transaction, it goes to the, let's say, mempool, block producers, and all these things come, they short it out, they fight amongst each other, and it gets executed with all the procedure L2s sequences will come in. I'm not going there, but how predicate is coming. Let's say I just confirm the transaction, then is predicate coming in that stack, or how it gets flows?
Yeah. So let's take an example of let's say we have a bridge that let's say you're bridging through some like token bridge, and that token bridge is integrated. What happens there is the transaction when you're first connecting to the wallet and hitting submit, before you're actually submitting to the mempool, the transaction is first broadcasted to our operator network. And the way that happens, and you won't even realize it. You as a user won't even realize this is happening. It's only happening on the back end. So the UI is essentially broadcasting the transaction to the predicate middleware. The middleware for us is basically something that choreographs and coordinates the transactions and broadcasts them to the operator network. So these transactions are then sent to our operator network. Our operator network says, okay, we need to check this transaction. They do that. They issue the signature. The signature is then issued on chain. So when you actually hit submit for that transaction, on let's say you're using your MetaMask and you're hitting submit, there's all this different text that's there. in that text, there will be a signature issued from our operator network that's being embedded in your transaction object. So when you hit submit, the transaction only goes through the smart contract and goes to the mempool because it has a signature from the predicate network. And that's because the application will have made an update to their smart contract saying the transaction can only go through if it has a signature from predicate. So for you as a user, all that's happening is you're getting a signature. It's a signature issuance that's happening from predicate, and you're submitting the transaction with the signature. Once you do that, your transaction goes to the mempool and does all of those things to then have final settlement.
Like one curious question. Okay, if we are adding a lot of stacks, right, in the entire transaction life cycle, won't that be like it will slow the transaction
Yes.
execution, or it will be like very fast? We won't realize something like that.
Yep. So it depends here on the type of compute. This is also why we did cryptoeconomic security. We didn't use ZK because ZK was going to be too slow and expensive, and as a user, you would very much realize it. And I think ZK will probably speed up over time, and then when that happens, we can, of course, explore shifting to a ZK model. But it depends on the policy. So for some of the flow of funds checks, it's sub-second latency. So it actually won't really affect the user experience too much. You, for most cases, you won't notice it. For very, very high frequency things, you hypothetically could. So it just depends on the application. But it is sub-second latency. And it really just like, this is why having a distributed operator network is valuable, because the way we think about it is the fastest signatures are the ones that are processed. So whoever is issuing the signature the fastest is the one that's going through. Whoever is slowest doesn't actually make it. This was the other value of why you have a distributed operator network, is you're able to optimize for the fastest speed based off of location of those operators and where that user is submitting the transaction. The latency
Yeah.
considerations here are your operator compute, that's sub-second. Now, if you're referencing any type of off-chain data, you're making external API calls. And so our operators are making external API calls. That you're limited by the speed of those APIs and the speed of the internet. So there's always going to be latency, very similar to Oracle networks, right? So Chainlink, Pip, all these guys have latency because they're making external calls.
Cool. I think I have to dig a little bit about the technical aspects to ask you more quality questions. I think that can be happen sometime later. But I think moving on, one thing you mentioned in many of your talks is that like Predicate is a three-side marketplace, and I
Yeah.
think we like explored one part, which is the operator network. Then the other two parts, like if you can explain that and like how this three-sided marketplace comes in.
Yeah. So the three-sided market here are operators, as you mentioned, applications integrating predicate, and information providers, external information providers. So we've already covered operators, so I won't go into detail for there. Applications are the ones who have some demand for policy, right? They're the ones who are creating a policy. They're the ones who are creating that pre-transaction logic. Then you have information providers. So there's two forms of information providers. There is what is natively built into the protocol. So that is archive nodes. So being able to, our operators functioning as archive nodes, and they can pull any historical on-chain information. The other thing we built into the protocol is the ability to create dynamic social graphs. So these are essentially the ability to create any type of connection between one address and another, EOA to EOA tracking. So you can say, hey, I want to create a dynamic list, whether that's a black list, a white list, whatever that is, you can do flow of funds checks. These are maintained by the operator network. So this is within the protocol. Then you have external information providers. We offer economies of scale to external information providers whose data can be used to enforce a policy. So different types of external information providers. These could be KYC providers. So if I'm an application and I want to integrate multiple different KYC solutions, I integrate Predicate, and then I can choose saying, all right, I want these 5 different KYC solutions integrated into my policy. So that way a transaction has to be checked for 5 different KYCs. Another group could be someone like TRM, the compliance and risk score provider. So if I'm an application and I want to use TRM for risk scores for pre-transaction checks, I can do that. Another one would be someone like Hypernative for anomaly detection. So I want to check if this transaction is an anomaly, and I want to block it if it is because I don't want an exploit to happen. That's another external information provider. Another one, which is an AVS, is Witness Chain. Witness Chain is geolocation. So you can use Predicate to be able to integrate policies that involve geolocation. So these are all external information providers. And what we do is we can create a marketplace for that. So if I'm a developer, I say, okay, wait, I have these requirements. How can I select an entire set of different information sources to be able to create my policy? And the great part here is for a lot of these, you don't have vendor lock-in because you're creating an open marketplace. So for us, we're like, what if we can create an open market for me to use any source of information for my pre-transaction logic? That's your three-sided
I
network.
think I think like how I am drawing a parallel is it is kind of very parallel to what Eigenlayer is doing with the AVS network, like creating open markets with all the AVSs. But like Predicate is going one step deeper, specific to pre-transaction requirements. Like I think Eigenlayer is a four-sided marketplace, how they give the analogy, and I think similar to what Predicate is doing in the three-sided model, and we can get all the things we need specific to like pre-transactions and like pre-execution, something like that.
Yeah, that's right.
I think we discussed pretty much like not like very detailed stuff, but an overview of what predicate is. I think you have talked in detail with all the technical aspects with in roll up. I think for that kind of discussion, I think it's better to have a presentation type model
Mm-hmm.
because we need diagrams and all to set up. But I think we'll move to the next part of the conversation, that is about the product, and not the product, the use cases part, right? Like I want to know in detail, like what are the type of applications which are currently building on predicate, which are live, which are about to go live.
Yeah. So some of the different ones that we're working with. So one that is just about live is Alio. So Alio, privacy blockchain, and for them, they passed a governance proposal. Their ecosystem passed a governance proposal that all bridges should have some form of AML checks before a transaction is bridged. And so the way they actually set those requirements, and so this involves a mix of like rate limits, flow of funds checks, geolocation, a number of different pieces. They're basically using predicate to be able to do those checks. So any inbound transaction to Alio is checked by predicate. So that's one. Another one that we're working with, which we'll make public soon, will be Plume. So in that case, basically Plume, RWA focused L2 that's actually shifting to an L1. So for them, similarly, they have requirements for inbound transactions from all bridges because they're creating somewhat of a garden for RWAs, right? And so they have to have certain things at a baseline that are enforced. So that's another one. We're working with M0 for stablecoin minting requirements, and Mento protocol on Celo also for stablecoin minting requirements. And then we're working with a few projects that we're discussing geolocation types of pieces, as well as anomaly detection. Those will kind of come more public in the future, but not, we're still finalizing those. But
So
yeah,
like
I forgot to mention, intent protocols that we're working with are Solana, Essential, Fabric. We're also discussing pieces with Near as well for chain abstraction. So we're also like quite deep on the intent side of things.
I think currently how I am understanding, they are kind of working on a very one-on model, or like not. I think the marketplace is obviously not live at this moment, but like how, let's say somebody wants to like build using predicate or some ideas, like how they are contacting, or let's say if somebody's hearing this podcast, how they will reach out to you, like on Telegram or Twitter DM, something like that.
Yeah, the best way to get in touch with us is either Telegram, Twitter DM, or on our website. We have a contact form there. And what we'll do is right now it's a bit more of a white glove approach where we work individually with every project on setting up their requirements and integrating predicate. In the future, this will be more self-serve, but right now it's just easier for us to be able to work directly with those projects. And then part of our roadmap is making the system more and more generalizable and self-serve as well.
I think as like you just mentioned about the roadmap part, like basically where we are exactly at the roadmap for predicate, and like let's say for the next 2 quarters, I'll not go beyond because crypto will change
Yeah.
completely. 2 quarters is a lot. Like where we are at currently, and let's say next 2 quarters where predicate will be according to you.
Yeah. So in the next 2 quarters, the main things that we'll see will be a number of additional use cases that are live across a number of our partners. So we'll have like 3 by roughly the end of this year, and then we're thinking like anywhere from 10 to 20 next quarter. Different like large integrations. So that's going to be one item. The other one is making our system more generalizable compute, uh, pre-transaction compute, but much more generalizable. So you can have a lot more flexibility here of like, what are those pre-transaction things you want enforced. So that's going to be another big item for us in the next 2 quarters. Another one is the actual like front-facing UI and interface work. So for if I'm a developer, if I'm an ecosystem, I'm a community, how do I set my actual policies having the UI and the tooling to all be able to do that, that's something that we'll be spending a lot of time building on as well. So I think those are some of the main things that you'll see in the next few quarters from Predicate.
I think before we wrap up, we do one small thing like with all the founders. That is three questions you have to answer under 1 minute. These are not necessarily new kind of questions, but everything we discuss, I'll ask you three questions and you have to answer them like under a minute. Basically, you can take a minute. Don't need to answer in 10 seconds, but yeah, that's the flow basically. So
Okay.
the question number one is what's predicate?
Predicate is a system for simplifying transaction prerequisites.
You can go a little bit deep, but that's why I mentioned that you can
Okay.
like kind of explain it a little bit details. So
Okay.
yeah, yeah.
Yeah, so Predicate is a system for simplifying transaction prerequisites. So really what we are is a network for being able to set any type of custom pre-transaction logic for on-chain applications, intent systems, solvers, anything that is on-chain, and being able to enforce that in a verifiable and open manner.
What are the three projects building on predicate and like their categories?
We have a lot, so let me think. 3 projects that I can say: Aleo, privacy; Plume, RWAs; and then let's do Kalani for intent systems.
Hmm. I think the last question is like why you chose Eigenlayer.
Yeah. Why we chose Eigenlayer is because it enabled us to bootstrap our operator network and basically solve one of the 3 sides of our network and make that much easier for us to be able to just go live and really start working on integrations. And then more generally, as we think about like why Eigenlayer, it's because the team really understood what we were building and they were super supportive about all of that. And we thought that they are kind of that like the premier team to work with as we think about how do we power a very core part of our underlying protocol.
Cool. I think that kind of gives us a very overview part of what predicate is. I think it will help me to think better about what you guys are building. I'm sure like more exciting announcements are coming up soon with big protocol launches, and I think with more and more people understanding what predicate does, I think this is a kind of a product everybody will likely to use, especially when they're kind of expanding their operations. Even at the beginning, but especially when the protocols have gone big and need to have some pre-policy definements before a transaction even gets processed. So like looking forward to your journey. We'll keep a close track and like best of luck.
Thanks. And yeah, thanks for doing this. Really enjoyed it.